Okay, so what we did last time, right? So was introducing a new way of applying the large language model, and especially trying to build some program that can take care of some actions outside of the basic text input and output from large language model, right? So instead of just getting the text output, we want to create some kind of actor or agent that can do other things, can interact with other parts of the world. Okay, but we all know the core intelligence come from large language model, so we're still going to use large language model as a thinker. Okay, they will figure out what to do, but then we need to plug in all the different actors to take care of the actual actions. And then last time, I showed you an example of using the language model to build like a file organizer because handling all the file movements operation is like specific to your local computer. The general language model cannot really do that. They don't have access, they don't have permission. So we actually build some of the file manager and that just handles the very basic file operations. And then we create some, these different functions to take care of different things. And then we were trying to figure out how do we let a large language model to generate some kind of commands that can actually call this. And one approach we used was designing a domain-specific language. So we create our little language, and for different command, we run different kind of functions. Because the domain-specific language is also text-based, it makes it very easy for the large language model to um, generate the specification as the output, and all we need to do is to execute that specification. So that's how we can connect the large language model and also the actor together. So we're actually using a text-based specification as a kind of a middleman to connect the two sides. The reason we thought about domain-specific language was just because the language model is very good at generating text stuff. It turned out really good. Okay, so that's what we had last time. But then if you think about this a little bit more, if we want to extend this one, we often need to add more functions. That's always required. But then also we need to also modify our domain-specific languages, okay, as a new way to specify it. All right. But then if you really think about the domain-specific language, okay, it's actually really good, very useful. But then is that really needed? From the logical point of view, it only serves as a something that both sides will understand, will read, will agree on. Is like a protocol, right? Um, but the idea from LLM, large language model, they can already generate all the list of action they think they need. We just asked the large language model to confirm to this specific syntax and grammar and everything, and then we build another executor to run this one. So if you think more about this, this domain-specific language is not always needed. Okay, so for example, if somehow the large language model will just know how to call these different functions, like here, um, even some kind of like a in-memory kind of a maximum or Python maximum that they can just trigger and call this. We don't have to, really specify all this middle results as a text-based language like this. Okay, sometimes having this one is really helpful, but sometimes, either your action is too complicated, and you can't just put everything as a text. And then another thing is that you just have to maintain this language. Okay. So what I want to show you today is that there are different ways to build this type of agent that you can pretty much skip that domain service language so that it will just handle a lot of things internally. Okay. Now, with that, a main thing you want to know is there is a framework or a language called the LangChain. I don't know how many of you have heard about this one. This one has been a very like popular framework from the early days when the learning model got started. Okay, so they do a lot of different things, but the most important thing is that they provide a lot of LangChain libraries in Python that helps you to do all the different things in a very easy way. So for example, in many cases, we will need to call the OpenAI API and to get some results, right? So what we do now is this. So you specify the, let me find, where did we call the OpenAI API? We call OpenAI. All right, it should be right here. So we give the key, we create a prompt, and that's the whole prompt. And then we use this client that's from the SDK provided by OpenAI. We specify the model, messages, all the token stuff, and we get the results. That's the typical way to call it. So what LangChain can do is that they have their own wrapper that makes a lot of these things easier. You will still specify, the model, which one you use, but you don't have to just use OpenAI. You can use all the different ones. They make something very generic for you to do. You choose any kind of model, you give a prompt, the message, and then you can specify the tool, and we'll talk about the tool very, very quickly. And they create this generic framework for you to interact with large language model in much more like a simple and intuitive way. All right. But it's not just about these little wrappers. What they also do, just like a name specifies, called language chain. So they are able to chain all the different tools together and to let them to somehow cooperate with each other. And we don't have to specify how they're going to connect it or collaborate. We don't have to define any kind of domain-specific language, a text format. We just tell them, I have this many functions, I have this many tools, okay? And they can each do this type of things. Now, you please use the algorithm model to decide which one to use and how do you trigger it. It will make the whole thing much simpler. All right. So let me just show you examples. For the LangChain, you can probably find a lot of tutorial online. I'm not going to dive too much, but what I want to do here is I want to show you a Hello World example that I think just pretty much explain the goal. I'm going to start from this code right here. And I already tested. I'm not going to redo it. But this code is really good. I think it's a very good Hello World example. Okay. So a bunch of import from the LangChain library. Okay, so these are all for free. You can just import it. They're just frameworks. Now let's see what this code does. There are three functions in Python, and every function there is an annotation called to. And whenever you see annotation, it's basically just coming from some of these frameworks. The first one just say hello. All right, just do a greeting, say hello, and then with your name. Pretty simple. It just does very simple things. This is a hello world example. Nothing complicated. This one is to add a number to get a sum. Okay, so you provide a query, and we're going to find out the two numbers and split by, split by probably the spaces. All right, and then we just calculate the sum. Okay, the sum is a Python function that you can get all the numbers. But basically, this one here, we're trying to, parse the whole thing and get all the numbers there. That's the second function. The third function is an algorithm that reverse all the tags. Okay. Yeah, I don't know how this operators in Python works, but pretty much you can imagine there's some kind of operator that handle the characters, strings, just to reverse it. Okay, so we're not going to dive into too much about this one, and you can always come up with your own algorithm. As you can see, these are three different functions that do different things. Okay, the first one show a greeting message, the second one adding the sum, and then the last one reverse the text. Okay, so now I'm going to try to build an agent. The agent is going to include all the tools. Now this is how you build an agent. All right, so the agent has a large language model. As you can see, this is coming from the LangChain library. So they have a wrapper for the chat OpenAI because OpenAI is one of the very popular model to use. And what you do is specify which model you want to use. We're going to use a mini one. It's cheaper, it's faster. Temperature is one of the parameters, and also the API keys. And then you don't have to put the keys here. I just like to put it here so that I don't have to always do the export stuff. Okay, but in a best practice, you shouldn't actually put a key here. And then you create an agent. All right. As you create an agent, you have to tell the agent which large model to use. And this is the one we just created. Okay, we're going to use OpenAI, this specific model, the key. And then more importantly, you have to specify the list of tools you have. As you can see, the tools is a list and has multiple functions. And these are the three functions I just mentioned above. Okay, greeting, add a sum, and reverse the text. All right. And here is the system prompt. You are a helpful assistant. Use the provided tools when useful. Okay, it's a very generic one. Okay, I told you all the tools, and you just need to use them as you need. That's how you create an agent. Okay, you basically create all the functions and then put them together, give it to an agent, and also we supply a large model. As you can see, what the LangChain is trying to do is trying to combine and connect everything, all the resources together. And the LangChain will actually know to use the large model to generate the action plan and use the tools to take care of the actions. That's what they're trying to do. All right. But then you might be wondering, so how do the agent know what tool does? So if you look at here, there's some kind of comments. And if you're not familiar with this one, this type of a comments is the kind of a formal document kind of comments. For example, if you show your mouse over to the function here, you will be able to see that explanation. For the purpose of functions, that explanation comes from this comments. Now, if you're familiar with Java, this is similar to the Java doc. Okay, the formal comments, not the regular comments you put in the code. All right. So the logical model or the agent will actually understand the purpose of the tool by looking at the documentation, the formal documentation or comments here. Okay, that's how they can know which one to use. All right. So move forward. There is a function called invoke agent. So we're going to call this agent. Okay, and then we are going to give you the user's input, which is this one. And we just need to send this one over and to the agent that we call the invoke. This one doesn't do much, just send the input. All right. This one is just to generate the summary. We'll look at this one at the end. This one is to show you all the trees, all the stuff. Both of these are for debugging purposes. We can ignore them for now. Okay. But to use this one, actually, let's see. Okay. Right here, I'm going to create an agent. And then I'm going to create a list of prompts to test. The first one is something called say hello to Alice. The second one is add the numbers, these two numbers together. And then the next one is reverse the text LangChain. Okay, so the user gave three inputs. These are general natural language. This is not to call any specific Python functions. It's not in Python. This is natural language. And the good thing about this is the tool didn't specify what you should say, what kind of a syntax, right? Like the DSL we use, you have to follow the specific syntax, but this one is just a language. All right. So we're going to test each one of them. All right. And then let me see if I can just comment on them. So yeah, I'll do this one. All right. I'll just test the first one. Say hello to Alice. And then once we have the prompt, we're going to send that as the input to evoke the agent, and then we'll get the results. And then you can see all the results falling here. Okay, I'm going to run this code here. First of all, I think I need to activate my virtual environment. Okay, I'm going to run Python. Okay, so let me clear this one. I'll do Python and save the file and then chain example. All right, so once this one runs, let's see what happens. The prompt we use is something called say hello to Alice. And here is exactly what happens. And the user said this, and then the system request tool, we're going to call this tool called say hello with the argument, the name is Alice. As you can see, the LangChain framework automatically figure out that based on your input, we will need to use this tool called say hello. And the say hello need a parameter. And based on your input, I know the parameter is someone called Alice. Okay. And then the tool responded with the result called hello Alice. This part coming from the tool because that's what the tool does. All right. And assistant, that's just the results, and that's the final reply. All right. So this one is very simple, okay? But let's go through this one more time. We send a prompt input called say hello Alice. This one go to the agent. Once they hit the agent, they're gonna use large language model as a thinker to decide based on this input what kind of actions we need to do. And the large language model, because they understand the three tools, and the large language model figure out, okay, we need to call this one with the name as the input called Alice to execute it. And based on that, they will know to call that function for us. As you can see, the internal logic part, okay, that whole thinking and execution or taking action part has been combined by this agent, which is handled by the framework called LangChain. That's how it works. Okay. So for example, we try different things. Okay. I want to say, please give a nice and warm welcome to Alice. I use a totally different prompt. Okay, so I'm gonna change this. I'll just run this once. And this one should be able to figure out the same functional tool based on what I'm trying to do. Right? So as you can see here, and this is a new prompt, and then this one they still know we're gonna call this function called Alice, and then we call it, and then it said hello Alice. All right, and that's what we see. All right, so you just do the regular input. The large language model is still gonna handle it, but instead of just giving the regular response, they will know what tools to call to help you to run the actions. Let's see other things. This one, we want to add a number, the two numbers here. Okay, so I'm going to run this code again. All right, so we want to add these two numbers. And then it figure out the tool to use this function called add numbers. And with arguments, that's 2.5 and 7.3. We figure out where the numbers are. And then we call it. The result is 9.8. All right, and the final reply is this. All right, so they will know they can use the second tool. The next one, please reverse the text called LangChain. And then we run this again. All right, so we got an input. We know you need to call this tool called reverse underscore text, and with argument called LangChain. And the result is this one. All right, so that's how it works. So the large language model is still the brain, okay? Is the thinker, is the decider, but it will know automatic calling of functions, okay, as tools. All right. So lastly, if we see this little bit more complicated example, reverse the result of adding 88 and 99. As you can see, this one, it involves calling two tools. Okay, first of all, you got to calculate the results of 88 and 99, and then you reverse results. Okay, so if I run this one again. All right, so this time the result is still very good. So I gave this a prompt, and they got it, and then they figure out the first tool to call is called add numbers, and with the argument called 88 and 99. So they got the results, which is 187. And then they know that they need to call the second tool. The second tool is called reverse text. The reverse text takes the input as a text, so we just provide that output, which is 189, 87, and then they're gonna reverse the text. All right. So this example is very simple, but I think you can see it's very powerful because they know that there are multiple tools I can use. And they know that based on what you requested, I can break down the task into sequence. I can call them one by one. I also know how to connect the input and output together. All right. So think about if you are using our old approach, well, you had to specify DSL that specifies all the different commands. And then you want to make sure that they can generate this one in the right sequence. So the LangChain does the same thing, but we just don't know how to explicitly specify that. It's all stored in the memory. They will know what to trigger, what to call. All right. So that's the power of LangChain. All right. Any questions so far? So following this structure, okay, we so the tool is called LangChain, this one. So this one is a framework. Send in the chat. Okay, so it's a Python framework that facilitates how you actually interact with large language model, including building all the different agents. Right. And then also I try to use the tool to actually create the first example. I'll just show the example. Okay, so the all the code are actually generated, so it's pretty straightforward. This time, as you can see, we still have tools. And let's see what tools we have. The first tool is called a create a folder. So create a folder at a given path, including any missing parents. And it does the folder creation. The second tool is called move file. Move file from the source path to the destination path. List files, given a folder, return the JSON array of all the file paths located directly in it. We also have another function called get file size. So these are the things that we created last time for file manager. Okay, these are the same thing. We just create different functions and then we mark them as the tools. But now we have the tools defined. So we will actually define our agent. This time we still use large language model. This one remains the same, mini model and same key. And as we create agent, we actually supply the large language model, but also we supply all the tools we have. Create a folder, move file, list files, and get file size. These are tools available you can use. And then we need to give it a prompt. This time you can see what this prompt does. So you are a diligent file organizer. We're given a path, a folder path, inspect all the files using the available tools, suggest a reorganization plan grouped by the file type, extension name, and create subfolders when missing, and use and move files accordingly. Always explain your actions in the final reply. So as you create an agent, okay, you specify in a prompt what this agent is supposed to do. The previous example did something very simple, which is like use the tools as it's useful. Right here, use the provided tools when useful. This is very generic, but now we're more specific. I just want you to do the file organizer. I want you to organize the files by the file type. Okay, I want you to create a folder, subfolders, and move them accordingly. Okay. Once we specify all of this, and the agent will take care of all the things by itself. Okay, because they know the tools, they know your expectation, and then they will try to figure out how and which tool to call, what's the sequence to do it. Okay. This part, nothing really special. This is invoke it. This one is for printing the results purpose. Okay. So let's see, finally, the code is this. When we run this, okay, we want to ask the user to provide a path to organize, and then we're going to call this function. This function, all it does is to create agent and then create a prompt. And please analyze this folder and reorganize these files into subfolders by the file extension, create subfolders, and we send this prompt to that agent. And then you see the results. Okay. So I did some tests earlier. Okay, it went really well. So let me actually try to redo this one. I'll move all the files over. These are different types. There are Word document and images, PDF. Okay, let me just add some more files. We'll just add some more files. Okay, so this total 6 files. And then I go back here, I'm gonna run this code. Okay, so once again, I'm gonna provide a path, which is this test folder 1, and then they are going to analyze it, all the files, but of course calling the tools to list the files. And then they specify the type, and then they run the folder creation and also move around. Okay, so everything will automate it. So we run Python, LangChain, agent, and file system. All right, so let's see what happens. So they ask us the path. I'm going to provide this path here. All right, so that's the folder. All right, and then I think they're going to run the whole thing, and then finally they show the results. Okay, but actually, if you watch the folder right here, they are already doing it. They just create all the different folders, and then they're going to start to move around all the files. All right, as you can see, it's all done. All the files has been placed correctly. All right. So finally, they print out the result. We should actually change it to show the result as we go. Okay, so this is what happens. We input the folder. This is the prompt. Okay, please analyze this folder and reorganize the files into subfolder by subfile extension. Create a subfolder if it doesn't exist, and move each file in the right place. And here is the folder path. This is the 2 trees, and that's the path we use, the prompt we use. And then, so first of all, we call the tools called the list files, so they know to call this one first. Okay, in the last class, I actually explicitly called that one first, if you remember that. But now we don't have to specify because they know they need to know the files first. This one responds with the results. As you can see, these are all the files. They put it into JSON, all the file name and the path. After that, well, they will know what to do. They know to create all the different folders. Okay, they need to create folders for the Word document, SP3, MP4, PDF, PNG, and others. Okay, they even have others. Okay, because the large language model is a very diligent file organizer, so they know they also need to create another one. And then they just call the tool, create the folders. And then they start to move files. And then this file from here to here. And this file from here to here. So they're just gonna move all the 6 files. Once that's all done, they also did a summary. This is what I did. I create all subfolders, I move the files, and this will help you, this one, blah, blah, blah. All right, now it's finished. But this time the code is a lot more clear, and it's actually a lot simpler because we don't have to really think the logic, like the sequential logic, which one to do first, which one to call. The learning model should actually do it. All right. I really want you guys to understand and try the 2 examples because by building this kind of code, you will start to feel there's a new kind of a way of coding. Because I want you to compare this one. If you remember, last time as we built this one, the final code I did here is that this one, we actually specify the sequence, if you remember the prompt I gave. So see, there are different steps. The first step, we got a folder name. The second step, it would generate the folder summary. And the next step, we call the API. Next step, we ask for the confirmation. And finally, we run that DSL. We actually specify the steps in the prompt. So because as a coder, I know this is what you need to do. You have to call that list of tools first and then get a summary. And then you call this one, blah, blah, blah. So we're still thinking as a traditional coder where you need to design an algorithm and to tell the machine what to do, what to execute step by step. Okay, so that's the traditional way of thinking. That's what you has been taught. Anytime you are solving a problem, you have a algorithm. Okay, but now this code, guys, it does the same thing, but I don't know if you realize that you don't specify that algorithm anymore. You provide the prompt. Okay, this is the prompt you provided, and you provide the list of tools. The algorithm we did not specify. I did not tell the agent to call the list files first. I didn't ask the agent to do other DSL stuff, but I gave you the goal. I gave you the tools available. Now you figure it out. All right. I think this kind of a way of building programs and applications is very powerful. Um, to some extent, it's very intimidating. Okay. Now you think about now, you still do all this algorithm stuff. It's already become less and less useful. I won't say it's less useful, but you don't have to know those. All right. It's almost like you go to a restaurant. Okay. All you want to do is look at the menu to see what I want. Okay. In terms of how confident they're gonna make that one, what's the step, the ingredient, all the cooking stuff, you don't worry about it. Okay. So this way of coding actually really lifted the software development into another level. It's almost like right now when you write in Python, you never need to worry about how the assembly language works. But the truth is that the Python will all be translated into assembly, eventually into machine code so that the machine can execute it. But as a programmer, we don't have to understand assembly today, even though you guys took the course, but it's pretty much useless. And now I'm saying that you just have in the future, or not future, like currently, it's already happening. You just specify what you want, and you can pretty much ignore the algorithms. All right. So with the LangChain, the framework didn't do all of this. The magic or the intelligence is still coming from the large language model. It's coming from here. It's still the OpenAI actually understand what you want, have a plan on what to take actions. LangChain is just kind of organizer that connects everyone together. Okay, so I really want you to understand these two examples right here. Okay, these two examples very important. You don't have to actually look at the documentation from here. You can read some very basic stuff, but what I would do is just use cursor to generate the code based on what you want to do, and then you tell them to use the LangChain library, and then from there you try to understand things. Okay, I think you don't have to read the documentation for the whole thing to understand a lot of things. You could actually find a lot of LangChain tutorials, online courses. There's some of those, but honestly, when I was doing this one, I didn't look at those. I look at a couple of YouTube videos. I know what this one can do. When I was trying it, I just asked Cursor just to create a code for me. All right. So guys, this one is a very um powerful. Okay. You can pretty much build a lot of complicated agents, um, and also fairly quickly. All right. Any questions? And the library has a lot of things. They have another one called LangGraph. Okay, so I haven't really tried this yet, but what I understand about this one is this one is like a little bit more parallel. I think LangChain, you think about the chain is more like sequential. This one is maybe more like a distributed. That's my guess. Okay, I'm gonna look into this one and hopefully I can bring you something next week. And another concept related is something called MCP. Some of you probably also heard about that one. So I will try to cover these two more things within the next couple of weeks. Okay, but I don't want to overwhelm you. And these two things, okay, let me actually push this one to GitHub so that you guys can see it. All right, so we have a prompt engineering. All right, so this one will be AI agent with uh, LangChain. Let me just delete these. This is not a best practice, okay, but for development, it's just a lot easier. I like to put a key still explicitly, and then you should always just uh, change your key afterwards. Okay, so I'm gonna push this in here. Push the all right. All right, so that's the examples I just mentioned. I'll send it in the chat. And then let me also push the ones we did from last time. So AI agent with basic DSL. So this should be it. Okay, push this project to GitHub. Have you all decided which project to work on for the agent? Give me some examples. How about Carlos? Anything decided? Oh, everything. It's a game. All right. So okay. So this is the other repository. All right. Anyway, guys, that's all I want to show. Okay, so hopefully that helps. But that was a very quick demonstration. But you gotta try this. Okay, but I told you, even using the LangChain, you don't have to write it. Just use prompt to help you. And then in the beginning, try to stay with a small example. Don't get too much. A lot of things are too much for you. So get a simplest example, run it, and once you understand, and then plug into your own stuff. Okay, there are a lot of things you can do. Okay, I don't want to go through this. So the other example, this one I'm trying to build an agent to generate a website. It's not fully functional, but I can definitely see how it works. Uh, so basically, if you ever use things like a Lovable or some other AI code generation tools, they didn't build a large model. They just use all these tools and then build an agent that helps you to show those size stuff. Okay. All right. Anyway, I just want to stop here. Please start working on your project as soon as you can. And we got a 1 month left. Okay, I will still show you other things. Okay, within the next 1 or 2 weeks. These things are all very, very trending, very new. Okay, and never exist probably half 1 year ago. So please stay with the trend.